Well, I've been noticing of late that people are very obsessed with blinking cursors. I don't know if you've seen this. It's sort of like the thing you see right before a really cool demo. But there's a lot of conversation. You know, I'm always interested in the infrastructure software world, what people are doing with what we call cloud nowadays. And from what I can tell, they're really interested in managing clusters of blinking cursors, right? So they got these, whether you want to call them a node or a server or whatever, they spend a lot of time thinking about how would we bring up a whole bunch of blinking cursors. Like we're going to maybe have an operating system that we want in there, and we want to coordinate them somehow and have them network together, you know, kind of manage that stuff. And as these blinking cursors start to go stale, maybe we don't like the way that they blink, we might want to bring them down and reboot them. But really, once we get this army of blinking cursors set up, then like that will kind of be something that like our job will be done with it. We'll be cool with it. And you know, I've always been more of like an application person. Like I like the UI layer and software that I can do things with. But again, I think most of the conversation that I come across nowadays is really very blinking cursor focused. Maybe you make the color a little different, or you could be one of those funny people who like puts an arrow next to it, or all sorts of little animated things like that. So, you know, I think basically what I was going to talk about is how you manage all these blinking cursors, sort of what you do with them. And it seems like, from what I can tell, this is sort of like the best approach that people have for managing whole clusters of blinking cursors. Now, it has kind of like a confounding name, to use some alliteration. It's called Kubernetes. Hopefully, if you've come to this talk, you have an inkling of what it is, because I'm going to do a very bad job of explaining what it is, just to warn you from the get-go. But essentially what it is if you're really into you know, bringing up a bunch of blinking cursors, or containers, to stop doing the little joke there, you're going to have these containerized applications, and you want a way of deploying them onto whatever server you might have, allocating storage and networking resources to them, monitoring their overall health so that if something bad happens to them, you can restart them. And then, of course, the thing that we've always been questing for, you can scale them, whatever that means. Like as you get more and more performance demands on them, you can set up more of them so that you can handle more workload being placed on them. And then conceivably, you would like to scale them down as well. It's always bad to be able to scale upward, but then not to come down from that height. But essentially, for several years now, this open source framework from Google, Kubernetes, has been really going for winning the whole blinking cursor thing. And it's been pretty successful heretofore. And just briefly, the way that it works is you create a pool of virtualized resources, so VMs, and you also have your virtualized storage and networking that you can use. And then you also create a registry of container images. These are the aforementioned blinking cursors that you're going to be putting on the containers. And then you give Kubernetes, of course, some configuration. And what it does on demand is it says, you have given me the command to basically take some of these containers, put them on one of your nodes, like a VM that you've created, and I'm going to put, based on what you've specified, these containers and this amount of them inside of the node. And then I might also make something called a pod, which is a way of saying all of these containers are related to each other and should therefore have an affinity and have better performance reaching each other. And then there's some other details like replica sets and the configuration that you use and how that's persisted that goes on and on. But the whole end goal is that you've got a cluster management for whatever containers that you might want. And it automates a fair degree of the kind of operational things you want to make sure that you can scale and you're resilient and you're reliable. And it also comes up with not a programming model, but a model for how you specify and configure all of that, right? So you don't invent many different ways per person or per team of people that's saying, here's how we are going to deploy all of our containerized applications. You have one standardized way of doing it. So this is the talk that this room is for. If there was another talk you wanted to go to, it's fine if you want to leave. But I named the talk this one because if you talk about Kubernetes thing, you can't acknowledge the existence of the word C. It doesn't exist anymore. But you know, I'm not really a Kubernetes expert. I just kind of follow this space, and I've been trying to work out for the past year or so what exactly it is, why people would use it, what are successful ways of doing it, what does it lack, what's it really good at. And so finally, I'm going to use y'all, this audience here, as my guinea pigs to give you my little exegesis on what I've learned. Now, I don't have complete knowledge, so if you see any gaps or something's confusing, tell me, And then the next people that I present this to will be a little bit better well off, thanks to your efforts. So we'll see how things proceed here. So sometimes I like to begin my talk with conclusions because it's kind of late in the day and it seems like traffic's okay around here, but maybe you got to get home and you don't want to get stuck in traffic. You want to leave or you have to use the restroom. So just give me a few minutes and I'll go over the general themes, the conclusions of the talk. And the first one I think I've covered sufficiently for my desires, which is what Kubernetes is, right? Like think of it as a way of managing a bunch of containers. Now, if you really don't want to just go down the pure blinking cursor path, right, you're actually going to want to put software in there that does something, right? So inside those containers is going to be running some sort of software. And then it's essentially setting up the cluster of all these containers working together and doing some of the ongoing management for you and giving you some of the tools, whether you want to do it manually or do it automatically through APIs, of overall just managing those containers, right? So it's equivalent to like if I had a data center and I needed to figure out where to install software, how to configure all of the machines that I had, how to hook up the networking correctly and make all my subnets. It has a framework for doing all of that for you. And then we'll get into some other details about what it is and is not. So anytime I look at something like this, some piece of infrastructure, I like to keep in mind the reason that we're doing it, right? And it's certainly not to just get a cluster of blinking cursors up, right? As delightful as that is to like look at, it's nice if there's an actual reason that you're doing things here and there's software that's driving it. So I think it's always important to keep track of that. And I want to just speak briefly of a way that you can kind of think about what the purpose is so that you don't get lost in just a blizzard of blinking cursors. Now, next, if you are getting something like Kubernetes in place, or just any general platform, any cloud platform, there's a change in the way that you think about operating it, right? Like it's not sort of like we kind of traditionally do, where we build up this big wall of tickets and process, and we sort of hide behind it. There's a new way of operating that really lets you take advantage of what something like Kubernetes and other platforms have to offer. And if you don't change around to doing that, then you put in a lot of effort to re-platform your stuff, and then you're just doing the same old process on top. So that doesn't really seem worthwhile. It's a lot of work for just the same thing. So then on top of the operations stack, also if you want to do things in a Kubernetes way, or a cloud native way as people like to say, you have to change the way you write and architect your applications. Otherwise, again, you're not really taking advantage of the facilities that something like Kubernetes gives you. So you need to start planning out how you're going to change your application around and sort of understand that. And then finally, what I'll cover is oftentimes when people look at a new technology and they have maybe someone a little more skilled than myself convincing them that it's a great, wonderful idea and they should do it, the logical next question is like, how should we start? Like, how do we pick the first things to work on? And if you've got kind of like a long-term strategic view of the world, you start to think like, so in a largest organization that I work on, how am I going to scale up that success? So I can do 2 or 3 projects. Those will be successful because I know the people around here who care enough about their job to actually do a good job. But when I have to go work with other people who are like maybe like the way things are and I need to convince them to do things differently, how do I start to plan for scaling out to everyone and changing the way that everyone does things? So just briefly, this is an introduction to me. That's me right there. I work at Pivotal, and I spend a lot of time talking with large organizations about how they're changing the way that they're doing things, how they introduce new technologies, how they basically figure out how to do their software better. And in doing their software better, how they figure out how to change the way their business operates, which not very many people get excited about that. But I get excited talking with like technology people who like also think in a business way, and they're really figuring out how to manage their overall organization to operate better. I'm not very good at cost-saving stuff. That's not really my area. I'm more interested in how you do something new. So I've been an analyst at a couple of places, Red Monk and 451 Research, for about 10 years in total between those. And I was a programmer for about 10 years before all of that. And I live in Austin, Texas, so you have to serve a compulsory 2-year term at Dell if you work there. So I work there doing mergers and acquisitions, which is interesting. You get to talk with business people. They're fascinating, and you can learn a lot from them if you don't mind working with them. And also, if you're interested in more stuff, it's about a monthly column at the Register, and I write on Agile and DevOps and all this kind of stuff. And then I have It's usually weekly, depending on if our time zones align up. But I have a podcast called Software Defined Talk, where we talk about all this kind of stuff, and also, you know, recommendations for grocery stores and shoes to wear and other inane things like that. So anyways, please engage with my brand. Look how wonderful it is. So back to the regularly scheduled thing. So just as some proof, having been an analyst, I always need at least one chart in my presentation, or I just don't know how to function. But you know, there's good surveys out there that show the sort of almost, you know, the dominance in popularity of Kubernetes now as a place for running containers. And this is sort of a twice, you might call it a refried chart, if you will. It's based on a survey from the CNCF, so the foundation that houses and cares about Kubernetes. And I can't read the N here. You can get a copy of these slides. I know it's hard to click on these links at the moment. Essentially, they're surveying which orchestration frameworks you used for your containerized applications. And to read it for you, Kubernetes is the one that's way on top. And of course, Lawrence over at the New Stack kind of ran this through his way of cleaning it up and presenting it. But it does show you, and this comports with what you'll see in other surveys and market research, such as it is at the moment, that is the choice that most people have for how they're going to orchestrate and manage their containerized workloads. And it's not always the case that that's what they actually are using today, but it's what they're very interested in. And when I go out and talk with large organizations, that topic certainly comes up a lot. So it's worth looking into what this thing is and figuring out if it's applicable to you and how you would put in place a strategy, which is to say plan, that hopefully will succeed, of what you're going to do about it. So, as you might remember from the conclusions, I think it's good to start with why you would care about this, right? So, like, what's the end goal going to be of doing all this work? Because it's going to be a lot of work, and you know, you might want to do something else with your time. So, what I like to start with is this framing that I think ultimately you end up with any type of technology, and that is like, we're programming the software and then we give it to these other people and there's users and like they do something with it, as you might remember from your basic programming schooling. And what I think what people lose track of a lot is they lose track of what the final outcome of the software is, what the goal of using it is, how they're changing how the organization they work in functions, how they're, if you're into money, if they're driving more revenue and profit for them. But you really want to keep a close eye on, never minding how good and efficient we are at blinking cursor management, how are we actually changing the UI, changing the way that users interact with this organization and making the way that they interact better. Because if you lose track of that, you're going to be optimizing all sorts of ways that you program and run your infrastructure. And if you end up with the same result, then again, it's not really very worthwhile. You're not going to really have done very much. So always, especially when you're looking at something as new and sort of low in the stack as Kubernetes, always keep in the back of your head, I'm doing this to make the user's experience better, which will therefore make my organization better and operate more efficiently. So this is an example in the middle column of what I would call outcomes, right? Like the ultimate thing that happened because these organizations improved how they did software. In contrast to kind of like the performance metrics that us more nerdy type get all obsessed with, right? Like for example, it's great that you can do 1,000 production releases a day. That's wonderful, but like, did that improve anything? So it's good to kind of have that evaluation of the progress that you're making there, and always keep that in mind. So the next, you know, assuming that you've gotten the finger wagging about paying attention to the business side, and then you can quickly forget that, as most technologists do, and get on with your work. You want to figure out, how do I create a plan or a strategy for using Kubernetes or any kind of platform that I might have? And so before we get to that, if you do a talk on containers or Kubernetes, you have to have about 3 or 4 pictures of actual containers. Usually you start off with a single container, so you can build up the metaphor, but I don't really have enough time for that. So this is a lot of containers. So going on, you know, I think what you want to pay attention to is, first, when you're introducing something as wide-changing as Kubernetes, you want to think about, as we introduce this new way of running our infrastructure, right? And this is especially key for something like Kubernetes, because the goal of Kubernetes is not to run one application or run 2 applications or even 5. The goal is to run all your applications, as many of them as possible, right? Like it's a large scale chunk of infrastructure to run things on. So as you're doing that and you're progressing, what you're going to end up doing is trying to get more and more people to bring their workloads, their applications to your Kubernetes cluster. So you want to start recruiting people early on to come run on your infrastructure. And what people find if they don't do this is, I see this happening in organizations who are actively updating their infrastructure, is if they don't identify the applications that will be running on it and go and actually talk to the owners of those applications, the business side, they end up building a platform and then the blinking cursor is there and no one comes to do anything with it. So this has happened over and over again with organizations I talk with, is they get really interested in putting a platform in place like Kubernetes, but because they haven't recruited people to come use it, it just sits there just burning up money and cursors. So really think about who are going to be the initial people that come use this platform, and start working with them and recruiting them early. And start thinking about the conversation you're going to have ongoing with them when you need to prove that you need more budget, that you need more resources, that you should exist as a program inside there. So the next thing that you want to think about is, so we've got our cluster set up, and are we doing software, the custom written software that we write, in the right way such that it will even run effectively on Kubernetes or any sort of platform that you have? And there are a few characteristics that we'll get into that you use at the coding and architectural level that make it so that it is compatible with a kind of stateless, container-driven way of doing things. But one of the first things that you want to look at is, are we actually running our software process in a way that's going to take advantage of one of the core benefits of a platform like Kubernetes? And that core benefit is that if we do things correctly, we can deploy multiple times a day, or at least we can deploy to production every week, right? And the reason we want to do that is because we get this, if you remember your DevOps think and early Agile think, we get this fast feedback loop in place where whenever we get our software in front of a user, we can observe how they're using it and figure out things that we've done wrong, and then we can come up with new theories and ways of making our software more efficient, right? And you see this all the time in software where you know, like banking software is like this a lot. Like some task that you think would be easy and obvious is very difficult to find where to like change your, I don't know, the address of someone that you're sending money to or things like that. And instead of just releasing that every 6 or 12 months, if you can release every week, you can observe how people are doing these processes and improve them incrementally. So most organizations, however, are like this. And I realize it's hard to see, but don't worry about it. This is from the US Air Force, and it's a picture of the complete process of doing some new software thing, right? From procurement to specifying it to developing it to one day way over here actually deploying it to production and people using it. And, you know, that's more, the Air Force works on about like a 3 to 5 year cycle for doing things. So they're a little different, but most organizations I find operate on very, very long cycles, right? So if you're releasing your software on a long cycle and you're not going to be doing it on a weekly basis, again, that's something you want to start addressing early on, because you're going to go to all this trouble to put a platform in place, and then people are going to do deployments every 12 months on it, which is not that big of a deal, right? So think about, does the way we do software fit to what this platform is going to be doing for us? And then if it doesn't, how are we going to change that as well so we can take advantage of what the platform does? So next, once you have this platform in place, let's look at kind of the operational concerns and how they change. So if you think about the goal of putting a platform like Kubernetes in place, that goal being we want to improve the software that our organization is using. Part of how you're going to achieve that is by making it so when your developers are ready to release their software, they don't have to spend weeks after weeks going through all sorts of meeting with operations people and enterprise architects and security people to like get approval for the release that they have. And you certainly don't want them spending a lot of time kind of stuck in your IT service management sort of like paths of doing things, right? Like maybe all of y'all in this room are lucky enough not to have to do this, but back when I was doing development, you know, if you wanted to do anything that involves something other than your laptop, you would have to go to they would call it a help desk, like a ticketing system. And you would open a ticket and there would be like anywhere from 10 to 300 drop-down boxes that you would have to fill out perfectly, right? Like you would have to select, what project is this for? What stage am I? What is my desire? And typically, if you didn't fill it out correctly, you would have to wait about 48 hours, and they would send it back to you and say you didn't fill it out correctly, and then you have to do that over again, which is actually a pretty canny way to not have to do anything as an operations person. It's very protective measures that you have. So that way of doing operations in a, whatever the intentions of things like ITEL and service management were at the beginning, operations has really become all about this protective process of making sure that no one touches our boxes or deploys anything to it, right? We're very resistant to changing anything, which makes logical sense. You know, if you sort of like encounter some of the early DevOps think there's this idea of a wall between development and operations, right? And what typically happens is your operations people, their job is to keep your software up and running, right? Like they don't want it to go down. It's nice if your software is there to use. And so they want availability and uptime, and they've got these SLAs to satisfy, and if the software goes down, they're in trouble. But what they've learned over the years is developers, they're writing all this software, works great on their laptop. And then pretty much every time the developers give the operations people the release to do, it brings down production. So it doesn't take that much of an understanding of psychology to figure out that logically what the operator would do would be to totally ignore the developers and never deploy anything, right? Because then that will satisfy what their jobs are. So again, this whole way that operations thinks nowadays doesn't really apply, and it's not helpful if you want to be deploying on a weekly basis. So that's a lot of what over the past, let's say 8 to 10 years, this whole like theory of DevOps has been trying to address. But it's been evolving into this whole other school of thought, again from Google, just like Kubernetes, called Site Reliability Engineering, or SRE, if you want to sound like you know what you're talking about. And instead of what SRE does, instead of this notion of DevOps that says you should have your operations people working hand in hand with developers, and they're going to be like full stack developers that control the entire infrastructure that they're running on, and therefore optimize the way that they're doing things with their weird little DSL languages to configure things and using public cloud and stuff to make life easier. What happens in an SRE way is, or an SRE mindset, is and especially in a larger organization, you build or you have a centralized platform that sort of codifies and standardizes the way you run everything, right? It says, when you want to package your software, you package it this way. When you want to talk about how the various services that your software uses integrate with it, you do it this way. When we want to track and manage how the performance of this application, we do it this way. And you also start to provide, this platform run by SRE people starts to provide services. Like if you want to have like a global cache that does a transactional lock on a piece of data and that works, you have to use this system. And if you don't want to use this system, you're on your own. Operations is not going to help you. So SRE is this whole way of thinking where basically you're providing a platform to the customers of the product groups or the developers. And you know, there's a free book that you can go read. It's actually quite interesting and instructful that kind of goes over this theory of, if we think about operations not as a service, we're using a wall of tickets, we never actually do anything, but we think of it as a product that we're providing to all the development teams. How do we go about managing that? How do we take a automation first stance to fixing everything instead of manually doing it? And how do we change the way that operations functions? So you want to go look that up and figure out how that runs, because once you get your cluster set up, that's the way that you're going to want to operate it in order to take advantage of what it affords you and does for you. So the next point is, so you got your blinking cursors all set up, your wonderful clusters. Things are going well, you're installing different operating systems. You've purchased some pivotal software to help you with that. I can pay my bills more effectively. Good job, gold star. Now you're going to actually want to put some software inside of it, hopefully, unless you're just looking to have those blinking cursors. And the style of software that you have is different than the way that we traditionally do software. And it's very important that you think about how, and sometimes how you rewrite your software or maybe re-platform it to fit in this mode of operating. And so, more or less, we call this way of doing software cloud native. That term more generally applies to infrastructure at the moment, but it's a way of applying very broadly 2 ways of thinking about how you do your software. The first one is kind of this old piece of oddly successful kind of like guerrilla marketing that Heroku did a while ago, called the 12 factors. And what these describe are 12 principles and ways of operating that if you are going to deploy and run your software in containers versus on VMs or in bare metal, containers that are very ephemeral and will go up and down so that they can scale and be managed more effectively. These are 12 principles that your software should follow if you're running in a containerized way. And they center around things like, well, if your container is going to be coming and going, then your storage is also going to be coming and going, so you should probably not depend on your storage being there. And instead, you should attach to what they call a backing service. You should attach to another service that manages storage for you instead of managing it on your own. And then because containerized things do a lot, because they're basically distributed applications, there's a lot of specification over how to do the port binding and the networking so you communicate between them, and on and on and on, right? Like, it's actually fun reading these 12-factor things, because I find that every time I read them, I understand them less and less, which is the best kind of knowledge. So you can sit there and kind of rotate through them and try to figure out what they mean. So that's kind of like a guide for how you think about writing the actual code of the applications running on top of your blinking cursor. And then the next thing that's important to start tracking is this wonderful, I don't even know what that is, a spiral spin piece of art. But what this is it's pretty old now, but this is a picture of Netflix's service architecture, how all the little components that exist relate to each other and talk to each other, right? And if you look at this, if you're an older person like me, you think, man, I'm glad I don't have to manage that anymore, and I've gotten a job doing whatever it is I do. Like, that looks really complicated and crazy. But in fact, according to sources, if you follow this kind of microservices approach for things, stuff actually operates better for you. And it sort of makes sense, because if you're familiar, just to summarize microservices, the idea, as is said right in the name, is that we should have as small as possible little chunks in our code, services that do particular things, specialized things. And because, as with any programming, because we've broken them up into small services, they're actually more resilient as a whole, right? Like, we don't have a gigantic monolithic application that has cross dependencies going each way. And anytime we change one part, we've got to go check all the other parts, and we've got to operate in lockstep. And so it takes longer and longer to release this actual code. I mean, if you saw my friend Josh Long talking earlier today, right? Like, he made a reservation system, and there are all these tiny little components that basically operate independently and work with each other. So the reason it's important to start thinking about putting your applications in a microservices architecture is, again, the nature of running a distributed container-based application is that you've got small components that are constantly talking with each other and coordinating over the network, right? And so you need to think about, will my application run in that way of doing things, or is it just one giant ball of a monolith? So these are two areas when you look at what's running on top of the blinking cursors, you need to start planning out and thinking on, as well as, how are you going to change this around? Now, there's some folklore out there that you can just take a gigantic existing VM and jam it in a container, and that will work out for you, which probably technically works sometime, but seems like, why didn't you just keep running it how it was? Like, what did you actually get by just moving this thing over to a different way of packaging up your application? So make sure that you look at those two things. So just to fill out more of my quota, oftentimes what you do in a talk like this is, so you had the ship full of containers, if you remember, that's maybe like one application that you have. But then something like Kubernetes, of course, is an orchestrator of many of those ships. So here we have a shipyard that demonstrates that for you, that all sorts of containers being orchestrated by cranes. There's a lovely one just outside my hotel room that's very nice to look at. So there's some more obligatory container clip art for you. So then once you get through thinking through, how do we recruit people to use this thing so that it has value to the organization? How do we think about the way that operations is going to run so it's not just the same old slow plodding sort of ticket rejection system of doing IT? How do we make sure that the actual software that we're running on this cluster is going to work on it, that it's written in a way that takes advantage of what it is, and also deals with things like storage not being reliable and dealing with load balancing and things like that? The next logical question, if you're interested in all of that, is basically, all right, so now we need to select some projects to work on. And this is a very critical area that as I've observed people fixing their infrastructure and putting in place platforms like Pivotal Cloud Foundry and Kubernetes things over the years, that a lot of them goof up on, right? So there's always a lot of pressure especially in large organizations, to have a big impact, right? Like, it's risky to do anything differently, and we're under all sorts of pressures, so we need to have a huge positive effect of what we do. So when it comes to selecting initial projects and applications to work on, they often pick the biggest, most mission-critical thing that they can find, because if they do that right, you know, it's just like a mission to Mars kind of thing. Like, people don't really get interested that, you know, you figured out the right way to make food taste good in space. Small incremental thing. They want to know that you've actually gotten to Mars and succeeded at it. But what happens when if you think about it, when you're learning how to use a new platform, you're using a new methodology for doing your software, you're going through all these different changes, and you're learning how to use them. Maybe all of y'all were like perfect students and you never failed at anything while you were learning, but probably you're going to fail at these things as you're learning. Because really the way that people learn is by failing over and over again until they figure out the right way of doing something. Now, you know, sometimes you can hide your failures, which is a good strategy, and only pretend as if you are perfect every time. But even in that case, you need to build out a system where you have the space to learn from something. So if you pick the largest application that you have to just stick on your Kubernetes cluster or whatever platform you may have, it's highly likely you're going to fail at that. So you've picked like the most important, biggest thing out there, and then instantly you failed at it. And then inevitably what happens is everyone says, oh, your ideas were terrible, as you just demonstrated, so we're not going to do that anymore. So you've already sort of like killed off your efforts from the beginning by picking something too large. So instead, it's pretty easy to interpolate from that. What I see organizations doing successfully is they pick a series of smaller projects. Now, these aren't just sort of like science projects or just kind of silly things like conference room schedulers or finally figuring out a way to pick where to go to lunch in like less than 30 seconds, things like that. But they're actual real applications that drive revenue or help your organization do whatever. It might be just an application that helps out with tool rental, or you know, helps people schedule when a worker needs to go out to the field and install some new device on a power pole or something. But you pick these applications that are smaller, but that are real, so to speak, that have some sort of actual impact, and you start to work on those, right? And this gives you the chance to do two things. One, it gives you the space to fail without blowing up your whole project. Or again, you can think of failing as learning, if you prefer a word that's more positive. It gives you the chance to learn how to do new things. And as you're successful at it, you build up these successful cases of how we use this new approach to doing software. And you then use those, like we've been a success at these 3 applications. And then when you want to do a bigger application for the 4th, you go back to the rest of your organization and you say, look, we were successful at these 3 applications. They didn't totally fail, so we'll probably be successful at the 4th one. And you know, people like me who work at vendors, like us saying that doesn't really go very far. You've got to start proving that internally when you want to scale up your success. So, and you can see that in effect at one of Pivotal's customers, Home Depot, like a giant retailer. They sell a lot of hammers and plants and stuff. But they started off very small and then slowly, as they learned how to use the platform, ramped up, and they've been quite successful at that thus far. So figure out how you're going to start small with the workloads that you're putting on there. Don't put big, complicated things. So speaking of, I kind of mentioned this earlier, but there's a lot of conversation in the Kubernetes world about it's really good for like legacy applications. And I was just talking with a friend of mine earlier about what legacy actually means, right? And I always think of legacy as basically it's this really important software that you have that probably makes all the money for the company. And you need to change it, and you really are really afraid of changing it. Like you don't want to change it. Because if you did want to change it, you just call it software. Like you wouldn't call it legacy software, but by calling it legacy, you're like, I cannot touch this code. Everything will melt down. And so there's quite a bit of hope out there that finally we'll have a way of just sort of like forklifting this legacy application and moving it over to this blinking cursor thing, and we'll have solved, ever since the dawn of information management, this problem of legacy management. And there are some stories out there of people doing that successfully who have done it several times and they're skilled at doing it, right? So it is definitely possible if you have the right kind of help and knowledge and the patience to move things over very incrementally instead of doing it all at once. But as sometimes in a room like this, I say the word Gartner and people they get very upset, but you know, don't worry about it. So as the prognosticators at Gartner are pointing out here, right? Like, and I think this matches what our intuition would be, that if you just take this very like slapdash kind of overly hopeful approach to moving legacy applications to your clusters, things are probably not going to pan out too well for you. So if you're targeting these legacy applications that are not going to be rewritten in that 12-factor way with microservices, make sure you get the appropriate type of help and knowledge to move over there so you can plan that out and not have it fail for you. So next, if all that sounds good, you're like, all right, how do I get a Kubernetes? And this is a good chart, which maybe you can't read the details of, so I'll tell you, from my friend Paul, who is on my team that I work with. And I think it's a general good rubric for figuring out which Kubernetes to use and how to get it, right? So the first thing, and this is, I think, the first question of any kind of technology at scale nowadays that you need to ask is, do I want to run this in public cloud, or do I need to run it on my own, right? Because there's very different answers to infrastructure questions depending on what that is. And if you do want to, and I guess I shouldn't say want, if you can run it in public cloud, then there's three main Kubernetes instances out there. I wouldn't call them distros, services. I think that's what the S stands for in each of these out there. Of course, logically on each cloud, and a few others that you can choose, right? And this is great because all of the sort of complaining and fear, uncertainty, and doubt that you hear around Kubernetes, they take care of all of this for you, right? They install it for you, they do the upgrades of the core system for you, they manage it for you, they scale it for you, they do all the infrastructure, so you don't have to worry about that. You just have to worry about kind of setting some policy around it and then actually using it. So if you can use public cloud, those are some good options for you to have. So then the next stage is, do you want to just run it on a laptop, right? Which probably everyone in this room would like to do, and there's a great option for doing that. There's Minikube and other things, right? So you can get it up and running on a laptop to kind of poke at it. And I mean, unless you're going to slide your laptop into a rack somewhere when you go to production, which maybe is not a bad idea, you're probably going to need to move on to another way of doing things. So then the next one is, so do you know what you're doing? Or as my friend Paul put it better, do you want help with getting Kubernetes running? Now, it's a very popular answer to say no, because after all, we're technologists, right? We know what we're doing. That's why, this reminds me of an anecdote. I think, I forget who was saying this, but this actress Mia Farrow was hired to write a biography, or I guess it would be an autobiography of herself. And she had someone come in and teach her how to use Word. This was in the early 80s or sometime around there. And this person was telling her here's how you use Word, you open a file. And she said, what's this red squiggly thing underneath this word? Why do I need this spell check function? And she said, oh, well, that red squiggly, that tells you when a word is misspelled. And this guy's name was David. And she said, David, do you think they would have paid me all of this money to write a book if I didn't know how to spell? You should take that feature out. And I think as technologists, we often think that we'll do things and figure it out. And so maybe you will. That would be great. But oftentimes you end up in this situation, a billowing tire fire of disaster, which occurs a lot. So then, if you think if you kind of need some red squigglies to help you out, there are many distributions out there. My company, of course, has one, Pivotal Container Service. Now we changed that C to a K. But there's other distributions that you can look at. But these distributions are similar to down here. What they do is they collect together the core of Kubernetes. They add in a lot of the missing things, the kind of layer of juiciness around it that you need. And they tend to be better at upgrading the core platform than doing it on its own. And this is kind of analogous to, if you remember or are still experiencing the OpenStack world, right? Just as one tip of the iceberg, one of the core problems people end up having with OpenStack is having the discipline to upgrade it in a timely fashion, right? So a new version of OpenStack comes out, and it's kind of a big deal to upgrade it. And once you kind of let that slip for a year or two, it's almost impossible to upgrade it, right? So you've got to think about how you're managing the platform on its own and think about all these different concerns that you have. Now, as I mentioned, there's some missing things, so to speak, from Kubernetes, right? I would think of Kubernetes any delicious piece of meat, right? There's the core piece of meat in here, which is really great. And then it's always, at least in my opinion, it's always wrapped with a nice layer of fat and skin that kind of adds to the flavor and mixes it all together, right? So over here is like, there's all the meat, the fat and skin, the spices that wrap around it, right? So you have to bring in, you know, as I was mentioning, sort of like your virtualized pool of VMs and things like that. So that's something that you need to provide. You've got to have your persistent storage, right? That's an external service that you need to work with. You also need a way of doing networking and the advanced routing on top of this for all your incoming and outgoing requests. And then you need an image repo, and then also, not to mention all the services like databases and queues and all of those types of things that your application will be using, right? So overall, that gives you an idea of essentially what I would call a platform, right? Like, it's not just a blinking cursor manager, but it's the overall platform that your organization uses to get your software out and manage it, right? And so this is from a white paper that I was not involved in it, but that some of my coworkers wrote a little while ago. And it catalogs in this dandy box all the stuff that's in a platform, right? And if you look through this, it has the infrastructure that you need. It has the actual, what we would call day two operations, right? So once you deploy your software to production, it would be nice if you could make sure it keeps running and monitor it and see how it's going. And then, of course, you have all of your software development things that it takes to just write the code and get a build that's releasable. And then my understanding is that security is really important, so you should probably have that. But if you think about what Kubernetes does, it really is focused mostly on this infrastructure part. And then, as we were just talking about, not even all of this infrastructure stuff, right? So it provides some great stuff over here and maybe a little bit of stuff that's going on over here. But you need to start thinking about how do we fill in this entire platform so that we can run our software. And there's a lot more information in that paper there. So to summarize, basically, you know, these are kind of the major points to look through, right? And again, what's important, and I kind of maybe laboriously started out with this, is like any piece of technology is wonderful, right? Like a Kubernetes or whatever. It'll do great things. But it's just one part of an overall system that you're building, right? And you want to make sure that the component that you have, in this case, your Kubernetes or whatever, is actually not only working with the rest of the system, but that the rest of the system is changing appropriately to take advantage of it, right? That you actually have a software process that cares about frequent releases and doing something with that. That the software that you're writing is done in a way that will work effectively in containers and so forth and so on, right? So this is a, you know, just a little summary, your yield strategy template of how to start thinking through that and kind of plan out what you want to do. But if you've been following this space for a little bit, maybe we just spent, let's see, I set this for 45 minutes. Maybe we just spent 42 minutes and wasted that time totally. Because there's this whole other thing that's been coming about. And I think maybe in the past couple of months, there's been several people prognosticating, saying that like Kubernetes days are over. Like, don't waste your time on that. Instead, what you want to do is you want to leapfrog over Kubernetes and go to the thing that's going to be next, which is this thing that they call serverless. Or if you're like a less exciting person, you call it like function as a service or something like that. People get all upset that there's actually servers involved in serverless, but it's a pretty cool name. We should use that. So the notion is that like if serverless is going to be this great thing, and it's even more easy than EC2, and it's even more easy than like VMware before that, and it's even more easy to manage than platform as a service, and it's even more easy than that like nice fat and skin wrapped Kubernetes thing that we have. Like, why would you waste your time on that? And again, tragically, we can go back to the OpenStack days where there's a lot of organizations who spent a lot of time building their own OpenStack thing. And after a couple of years, they had one that was working. And then like platform as a service came back in resurgence, and it was sort of like, congratulations, spending all your time building your own cloud. So it's worth looking into what this serverless thing is to see if you can ride the frog as our friend is doing here. So thankfully, I don't know, I mean, if you have access to this very expensive report from Forrester, it actually gives you a very level-headed view that kind of like gets over all the funny proclamations that you can get for free out there. And it gives you a good understanding. Again, think about like core piece of meat, juicy fat and skin layered around it to provide you the complete meal. I think that's what Jeffrey Moore used to call the complete solution. So you have this core technology of serverless, right? Which is basically, to summarize, a highly event-driven way of executing small pieces of code that can attach to services, right? So if you think of like an Internet of Things thing, consumer run, like I walk into my house and my key thing is all internet stuff, and it fires off an event to a serverless thing somewhere, and it says, Cote has entered the house. And then that says, all right, I'm gonna go to whatever database I have and pull out the plan for Cote. And then I see, the next thing that happens is I fire off the little, I guess it's not a stereo system. I fire off the Echo device to play like the latest Courtney Barnett album because he wants to listen to that. And then I turn on the lamp in the kitchen. And then those are two other calls that go off to a serverless function that execute on their own. They pull like the access that they need and the plan for how to do those things from a source that they have. They kind of execute and figure that out, and they say like, I know, I need to go talk to the lady in the tube over here, and then I need to go tell this lamp to do something. So they fire off another thing that eventually goes down to those two things and turns those on for me. And hopefully that all happens in like less than a few seconds. Because I don't know about you, but I try all this like Internet of Things stuff in the home, and if there's like a 5-second delay, I'm like, this is a piece of garbage. So like it's got to operate very quickly and effectively. And if you do thousands and millions of these things, it's going to be extremely costly. So the whole serverless model is this event-driven way of doing things that relies on a whole bunch of external services and ways of operating to make sure that you can orchestrate them all, right? Like it's very analogous to what we were just talking about. But if you want to get interested in serverless, I mean, it turns out, as you can imagine, that a lot of this platform talk we've been doing, it actually runs very effectively. It'll run serverless stuff very effectively on top of it. But it's another programming model that you need to look into and make sure that it fits with the way you want to do things. And then you can join the party of serverless and be like a flying Birdman in the air, enjoying yourself. So this is the last container slide I have. So it's customary in a container or Kubernetes presentation at this point, which is right before I try to pitch you something, to point out that containers break and things go terribly wrong, that they're not perfect. And I think this is a pretty good representation of that, right? This looks like you're gonna have to come in on the weekend and work because production just went down. And I think with that, this fulfills my mandatory quota of pictures of containers that you're supposed to use. So, anyhow, if you want to come over to the Pivotal booth, we can tell you a little bit about the platform that we have. But again, other than a crass little pitch here, what you really want to pay attention to is the overall big picture of what you're doing, right? Like, let's not just locally optimize on this one thing that we have, but let's think about all of the parts of the system that we need and how to most efficiently have that and execute it and come up with some sort of platform that satisfies those needs. Because otherwise, we're just going to end up with a cluster of blinking cursors, which is not a very good way to go about running a business. But I guess maybe it feels like an accomplishment in a certain way. So thanks for coming here to listen to this. I'm pretty easy to get a hold of if you want. I don't actually answer the phone because I'm not a monster. But you can contact me through Twitter or email or whatever. And it's easy to get a copy of these slides if you want. If you just go to kote.io/confused, and it'll be an intelligence test for you to figure out how confused is spelled. If you can figure that out, you can get the slides. But you can get a copy of them and click on all those things if you're really interested. Or if you didn't like this talk, you can download them and delete them in Fury. That'll be a way of getting back at me. But I always like to end my talks with this bit from the Agile Manifesto, because one of the things I found over the years is that large organizations in particular, they're not really good at sharing information with each other, right? Like in most large organizations, they're solving all sorts of complicated, important, interesting problems, but then every single organization has to solve them on their own, which doesn't really sound efficient. And I don't think there's really that much to keeping secrets of how you do things, maybe if you're like spies or something. But like really what we should be doing is sharing more broadly the way that we're solving problems and things that we're finding. So, it's good that you're here at a conference listening to people like me talk, but I would encourage you, like as you figure out things and you come across problems and as you fail and also succeed at them, think about how you can go to like meetups or speak at conferences here, or maybe even just like figure out whatever medium is and write something there, or do one of these long Twitter threads, but start telling people and helping them about how to solve these problems and how to change over doing things. So thanks again, and I think there's a little bit of time for questions if you're interested. Or not. Oh, there we go.
Can you throw more light on transferring legacy to the container way of doing things? If you can explain.
Sure. Well, so the question was, can I talk more about moving legacy applications over? How do I be that 20% instead of the 80% of failure, if I did that math correctly? Well, so I think the first thing that will probably preoccupy most of your time, that I was talking with that same person about earlier today, is how do we make this so it's not legacy, right? Like, how do we make it so that we feel safe doing it? And typically, like, if you remember all the way back to this great book that this guy Michael Feathers wrote, I won't use his perfect funny phrasing of it, but his point was that the huge reason that we're afraid of changing legacy code is because we can't test it, right? Like, if we could test it, we would have confidence that we could change it. So the first step that you're going to want to do before you even think about containerized stuff is make sure that you actually have adequate tests around your legacy software. Now that becomes problematic because in order to have good tests, you pretty much always have to change the code, and then you're right back at the beginning. So there's some methods of breaking up and finding what they would call boundaries of the code, the components of it that are more vertical boundaries, like an entire process end to end, and you break up your code and test around that. But you really want to get to the point where you can test your legacy code at first. So then the next thing that you want to do, once you've probably worked on that for, let's say, 6 to 8 months, if not longer, is you need to think about, it's good to just understand that if I break it up into a series of processes that interact with each other, right? And that's essentially the way to think about what you do with the container is I'm executing a process. How would I have these new boundaries that I've drawn, and how can I subdivide that into a series of processes that talk with each other? So you're constantly taking this big ball of legacy, and I guess there's the cases where your legacy software is a very well architected series of small chunks that are working with each other, but probably not. And how do I continually break up this legacy thing into a bunch of smaller pieces? And then oftentimes what you have to do in that is you might have, like, I've got 500 different subcomponents potentially, and it'll take me 20 years to rewrite all of them. So I should prioritize the top 10 that I work on that will have the most effect. So, I mean, the way that you do it at a technical level changes from whatever code you have, right? Like if you're converting COBOL to whatever Rust is, then that's going to be different than if you're converting like Java, classic J2EE stuff to like a Spring way of doing things, right? But the approach and the way that you plan it out, I think, is what's more important because it'll give you that safety net to not screw up along the way.
My knowledge is limited, but just a question on that. So why not write new cloud-native applications to do the legacy stuff and then dump the legacy rather than shifting the legacy to the
Sure, if that's possible, that would be great, right? So it's kind of like, let me use another metaphor. Like, I have an old house that was built in 1949, and it would be awesome if we could just knock that thing down and build a new house. But this conference doesn't pay enough money for that. So, we've got to deal with what we have and incrementally add to it and change things as they happen. And that's often the case with software that you have, is that you can't really just get rid of it all and rewrite it. Now, again, if that's possible, you should totally do that. That would be fantastic. But it's often the case that you can't really escape that. So you have to come up with these other methods of dealing with what you have.
Thanks.
Any other questions? Well, I have a question. Where do you get those hats from? Who's giving those away? You didn't have to take yours off. It's fine. I'm not going to take it. Okay. I'll have to go. Are they good hats? Should I try to get one? Okay. All right. I'll look into that. All right. Well, thanks. This has been very productive for me. I know where to get a hat now. So I'll see y'all later.